Okay, guys, section 9.6, systems of inequalities. Okay, so like I said, for this chapter, we're doing 9.1, 9.2, 9.4, and 9.6. Now, notice I did not include linear programming in this section. Linear programming is very useful. It uses systems of inequalities, but if there's something we have to leave out, I'm going to leave out the linear programming. It is very interesting. I would encourage you to maybe read the book, kind of see how it was used. I believe linear programming was actually first used in World War II to make sure the combatants were getting the correct nutrition, but that's a long story, okay? So linear programming is used for something we call optimization, maximizing things, maximizing profit, minimizing cost. So it is quite useful. But the basis of it is understanding systems of inequalities, and that's what we're going to focus on, okay? So for part A right here, it says to graph each inequality. Now, you remember how to solve an inequality with one variable. Remember, we would solve for the variable we'd represent on a number line. When we have two variables, you may have seen this before, we're going to represent our solution on a rectangular coordinate system because there's x's and y's, of course, okay? So the way I like to do it, there's different ways of doing it, is I like to first determine what I call a boundary line. Boundary line, okay? And what I'm going to do is I'm just going to rewrite the inequality as an equality, okay? Now this represents a line. X minus y equals 2, that's a line. I'm going to find that line because that's going to be the boundary between my solutions and my, I guess you could call them non-solutions, okay? So to graph this, it's in a form that it's probably pretty convenient to find intercepts. So say the x-intercept is at y equal to 0. If we plug in 0 for y, we just get x equal to 2. Pretty easy, okay? So I can go to my graph here. I can put in the point 2, 0. I can also do my y-intercept in this case. That's when x is equal to 0. Okay. So when x is 0, that tells me that negative y is equal to 2 or y is equal to negative 2. So that gives me my y-intercept. That's 0, comma, negative 2. Now this is linear, so I know I just connect the dots to get my line, right? Because the graph looks like a line. The other thing I want to point out is, see how this is a greater than or equal to? That tells me I'm going to use a solid line, okay? Because if x minus y is equal to 2, which is anywhere on the line, this will be satisfied, right? Because it can be equal to. So in that case, I use my solid line. So any point on this line, and you can check it, 2, 0, 0, negative 2, will satisfy this inequality, okay? Now, this is our boundary line. This is the boundary between our correct answers and our incorrect answers, okay? So the correct solutions, the solutions to this inequality could either be all over here or all over here. The way we determine that is you test one side. If that side works, then that's the correct side. If it doesn't, then it's probably the other side. So what I'll do next is I'll pick a test point. What a very easy test point is that we can use most of the time, as long as it's not on the line, is the point 0, 0. Let's make the math easy for ourselves, right? So if I plug that into my inequality, I get 0 minus 0 is greater than or equal to 2, which is nonsense because 0 is not greater than or equal to 2. So that tells me 0, 0 is not a solution. So I think my solutions are over here. Let's check a point we know is over here. Let's say like 3, 0. Let's make sure that works. 3, comma 0. I plug that into my inequality right here. That says 3 minus 0 is greater than or equal to 2, which is, of course, true. Since 3, 0 is the solution, I know everything on the right-hand side of this line, including the line, is a solution. So this is the way I could represent. I would shade that. So that's one of them. Let's look at another one right here, okay? So I'm going to try the same sort of thing. 2x greater than 3 minus 4y. So here's the thing I want you to notice. This does not say it can be equal, okay? So the line that I draw, are we going to be able to include those points on the line in my solution? We're not going to. To represent that, what we use is a dashed line, okay? So I'm just going to write myself a little note here. I'm going to be using a dashed line for my boundary line. Now, this is a little hard to graph the way it is, because if I write this for my boundary line, this is going to say 2x is equal to 3 minus 4y. It might be a little easier if I get the y over to the other side, then I can use x and y intercepts like we did before. So that would tell me that 2x plus 4y is then equal to 3. 2x plus 4y is equal to 3. Now it's going to be easy to graph using x and y intercepts. So let me get my graph set up to the right here. Okay, there's my graph. And let me go ahead and go through this. So for x-intercepts, this is when y is equal to 0. Okay. That means that 2x is equal to 3, or x is equal to 3 halves. Okay. So where's that going to be? That's going to be right in between 1 and 2. So this is the point 3 halves, comma 0. Okay. Let's look at our y-intercept. That's when x is equal to 0. Okay. If x is equal to 0, then we have 4y is equal to 3. That means y is equal to 3 over 4. When x is 0, y is 3 over 4. That's up here. So if this is 1 and this is 2, well, 3/4 is about right there. 0, comma, 3 over 4. Is this thing linear? Of course it's linear, right? This is a linear equation in 2 variables. So that means I can just connect the dots. But now I have to remember, this has to be strictly greater than. Okay? If it's strictly greater than, it can't be equal to. The solution is not on the line, which is why I'm going to use a dashed line like we mentioned before. Okay? So we want to figure out, well, which side is the correct side? Pick a test point. Like I said, I like to pick the easiest point of 0, 0 whenever possible. Plug it into your original inequality. This would say that 0 is greater than 3 minus 0, which once again is nonsense. So I think the solution is going to be up here. Just to make sure, let's pick a test point. Why not try 0, 2? So if I plug in 0 for x, that's 0 is greater than 3 minus 4 times 2, or 8. 0 is greater than negative 5. That checks out just fine. Oh, okay. My solutions are on this side of the dashed line. Okay. So that's how we handle regular, just single inequalities. Next video, we're going to do systems of inequalities.